This is a little video lesson to guide you in completing some of the iXLs for section L. This is just my way of helping you out preemptively. These sections are pretty self-explanatory, but I just want to make sure that we understand how to complete them. So for L1, this is polynomial vocabulary, and it's just going to be asking you some basic questions about polynomials. So for example, this one has find the number of terms in the polynomial. Well, the 5s to the 6th is the first term. The 5s to the 3rd is the second term. S squared is the third term, so this has 3 terms. The degree, as you recall, hopefully from lesson 3-1, the degree is going to be the highest exponent. So j is your only variable. Its exponent is 1, so this is a first degree polynomial. This polynomial has multiple degrees, the highest of which is going to be 4. You want to be careful with these because sometimes they will not list them in standard form. So you might have something to the 4th degree at the end. You want to make sure you look through everything to find the highest exponent of your variable. This one has a degree of 4. This one, again, degree 1. Let's see if we can find a different question. Number of terms, that's 1. Let's see if they ask anything else. Let's try skipping and seeing what they ask. Okay, so classify this polynomial. So you have linear, cubic, quadratic, or none of these. Linear is going to be when your highest degree is 1. Cubic is going to be when your highest degree is 3. Quadratic is when your highest degree is 2. If the highest degree is none of these, you would choose none of these. Now be careful because if you have a variable that has no exponent listed, but the variable is still there, that is going to be a linear of degree 1, not a none of these. If there's no variable at all, or if the variable is something higher, has an exponent higher than 3, then you would pick none of these. As this one has a highest degree 3, it is going to be a cubic. This one, highest degree is 4. Well, it's not quadratic, linear, or cubic, so we would pick none of these for that one. And again, classify the polynomial, highest degree is 3, so we would pick cubic. So this section should be relatively easy for you to complete. I guess this is also one that has not come up. Trinomial, binomial, monomial refers to the number of terms. So if you have 3 terms, that would be the tri. Binomial, that's bi, that's going to be 2 terms. Monomial is 1. This has 1 term, it's just m to the 9th, so this would be a monomial. So that's your L1. L2 is adding and subtracting polynomials. The only thing that really makes this one difficult is when you have subtraction, you need to make sure that you subtract everything in the second set of parentheses. So for example, the 3a is going to become a negative and the 2 is going to become a negative. So when I go through and actually combine these like terms, I'm going to have 9a minus 3a, which is 6a, and then 9 minus 2, which is going to give us a plus 7. So this solution is going to be 6a plus 7. Here's another subtraction. 9s minus 8s is going to be a 1s, and then 8 minus 7 would give us a plus 1. Again, pretty self-explanatory. This one goes a little bit further. Make sure you only combine things that have the proper exponents. So the 7z squared doesn't have anything to combine with. You would just put the 7z squared into your answer. Multiplication is also going to be pretty self-explanatory. Make sure that you are adding exponents when you multiply. So for example, if we're finding this product, I would multiply the -6 and the 2 together. So that's going to give me a -12. The w's then, I'm going to add their exponents. So w times w squared is going to be w to the 3rd power. This has an exponent of 1. This has an exponent of 2. So when I add them, I get 3. This one, you're distributing the d. So you're going to have -3. It's going to be d to the 3rd power. And then minus d to the 2nd power. So I'm going to be adding 1 to each of these d exponents. And as you move through here, if we jump a level here, because I can do that on the teacher preview, there's some binomials you're multiplying together. And if you jump further, that one's pretty basic there. This one, if you have a square here, remember this is 3a plus 1 times 3a plus 1. You can't just distribute the square. You do have to FOIL that. So be aware that those could come up. Once we do L1, 2, and 3, we're going to jump down here to L14. I really like this one because it does kind of go along with our graphing section. You're going to be matching graphs with polynomials, so you're actually going to be taking these and dragging them into their appropriate places. You can consider end behavior. You can consider what the y-intercept is of these equations to match them up, just whatever you think would help you make sense. So I see here I have two quadratics. This quadratic is negative because it's opening down, and this quadratic is positive, so it's opening up. And if I look at my two choices here, this one has a negative and a y-intercept of negative 53, and it looks like that would be reasonable to go with this one. This one has a y-intercept of 13, which it looks like it's approaching, and it's positive. So it looks like that one has to go there. So you can use everything that we've talked about with polynomials and end behaviors in order to match these up. So we have a positive cubic and a negative cubic. Well, here's my positive with 64, and that's going to be up in the positives there. And there's my negative with the negative 16. So I'm going to match those up there. And eventually you will get into some where you have to match more. Notice this one, this is a cubic, this is a fourth power. Well, cubics have to go in opposite directions, fourth powers have to go in the same direction, so that one has to be the fourth power. This one has to be the cubic, and you could consider the y-intercepts as well for that one. I think eventually they'll have you match, I think there's like 4 that you have to match. So yeah, you have one like this where you have 4 different graphs and 4 different equations. So you would have to go through and drag the appropriate one to each place. The last section we're going to look at is L.15, which is domain and range of polynomials. So this is going to use some of your skills for polynomials. Notice it says this is the graph of a polynomial. There is no absolute minimum or maximum because the arrows keep going up and down. It says find the domain and find the range. So we need to drag into the appropriate boxes. Well, since there is no max or min, and my arrow is going down into the left and up into the right, both the domain and the range have to be negative infinity to infinity because there's no limitations on what we can plug in for x, and we're going to get back the full spectrum of y values. This one, it says has an absolute maximum. So this is the maximum point up here at 7. Now this is a quadratic. The domain of a quadratic is always all real numbers. The range, however, the highest value I can possibly go up to is 7, and I'm going to equal everything less than 7. So this first option here, negative infinity to 7, that is going to be the proper range for this quadratic. Notice it says this one has an absolute minimum. It is another quadratic, so the domain has to be negative infinity to infinity. This one, the lowest it's going to go is negative 6, and then it's going to equal everything greater. So that's going to be the second option here. And that's all you would do here. You're just going to keep dragging and pulling in things. Let's see if we can jump to any others. These should all be pretty self-explanatory. Again, this is a cubic. Your arrows are going out and down and up and out. So both your domain and range are going to be negative infinity to infinity. This one does have absolute maximum. They're both at the same value of 8. This is actually a quadratic, or I'm sorry, this is a quartic, which is the name for a 4th degree polynomial. That's not something we went over in class, but that is an extra useful tidbit of information. So the domain, again, is still negative infinity to infinity. All polynomials are going to have this domain. And then your range, the highest that we possibly go up to is 8, and we're going to equal everything less. So that's going to be negative infinity to positive 8. So that's going to be there. So I hope this video was useful in going through the different sections and what the expectation is going to be. Go back and rewatch any of the parts that you aren't sure of or anything that does not make sense. And as always, reach out to me if you have any questions.